All right, Unit 2. What?
So you sound like you're about to give a lecture.
I am. I'm lecturing about 2.1. Okay, here's the thing in Algebra 2. We're going to introduce some new vocabulary. So I'm going to give you vocabulary definitions, and you are going to have vocabulary on a test. Now, it is matching. So what happens on your test is I give you, I think there's 20 words on the first one. So 20 words, 20 definitions, and it's literally matching. That's all that it is. Okay, so you don't have to memorize. You just have to know them. And you will know ahead of time what the words are, right? So when we do words like this where it says key terms, those are things that you will probably see on your test. So those are words that you're going to need to know. They're not hidden. In geometry class, some of the words are hidden in your notes. Not so in Algebra 2 very much. Okay? All right, so a quadratic equation, that's our first blank there. A quadratic equation. And I'll move out of your way, Kaylin. A quadratic equation has a degree of what? Ooh. 2. Quadratic means 2. That means x squared, right? Degree means the highest exponent. Okay, so degree means the highest exponent. So it's going to be x squared. All right, so if we look at this equation, f of x, have you guys seen f of x before?
Yeah.
F of x really just means what? What letter does that really mean? Y. F of x really is just a fancy way of writing y. F of x means a function of the x. Okay, and so we'll talk about more about that in Unit 3. But for now, just know that it kind of stands in for y. Okay, so we're going to talk about a quadratic equation. The definition of a quadratic equation is an equation, and I'm going to abbreviate equation with EQN. Okay? Equation with degree 2. No, it's fine. It's an equation with degree 2. Does anybody know what degree means? Like, why do we care about the degree of anything? Does anyone know?
It means like higher.
Okay, it's higher. The degree tells you how many times the graph crosses the x-axis. Did you guys know that? Just blew your mind, right? So every quadratic, every x squared problem means that it crosses the x-axis twice, right? So let's make a note of that. Degree 2 means that it crosses the x-axis 2 times or twice, whatever way you want to write that. It means it has 2 answers. That's what an x squared does. Okay? The quadratic term is the term that is x squared, right? So the quadratic term is the ax squared term. So that's the quadratic term. The linear term is the term that just has the x, bx. What is the degree of the linear term? 1, right? That x really has an exponent of 1. So we can maybe say that this has a degree of 1. What's the constant in my equation up there?
1.
C. Just the C value is the constant. It has no variable. It's just a number. So maybe that's helpful for you. Just a number. And I'm going to use the number sign. What's a coefficient?
A number that's by itself.
That's a constant.
The number with the variable.
It's the number in front of the variable. So coefficient is the number in front of the variable. So in this example up there, A is a coefficient, B is a coefficient. And c is not necessarily a coefficient, but it's a number, okay? This equation, f of x equals ax squared plus bx plus c, this is standard form of a quadratic. You know how when you were doing y equals mx plus b, everything was in y equals mx plus b, right? You did everything in y equals mx plus b. We're going to do everything in f of x equals ax squared plus bx plus c. Okay, that's what we're going to use the most. Okay, questions about that so far? All right. So now we're going to talk about a couple of different types of equations. The first type is called a linear. Okay, so that goes in that first box right here, linear. So underneath name, go ahead and write linear. L-I-N-E-A-R. Linear. Does anyone, yeah. Does anyone know what linear means? Okay, Brianna reminded us that the root word in linear is line, right? If we have linear, good. Linear, the equation that we typically use is, we already talked about it, y equals mx plus b. That's typically what we use. The graph of a linear equation is a what? It's a line. Okay, and what is the degree of y equals mx plus b? What's the highest number of solutions? You have something there? What's the highest degree? 1, right? And guys, remember I said that the number of degree represents how many times it crosses the x-axis? See how it's only crossing the x-axis one time? That's because it's only x to the first power. Okay, so the next type that we can talk about is quadratic, and we just talked about that. And we have the standard form of the quadratic. Let's go ahead and write that in this box from up above. Ax squared plus bx plus c. Does anyone know or remember what the shape of a quadratic is? Yeah. A U shape. Does anyone remember what it's called? A parabola. A parabola or parabola?
I said parabola.
Okay, well you should probably say parabola. Okay, so a parabola looks like this. Sometimes it goes upside down. And what's my highest degree? Look at your equation. What's the highest degree over there? 2, right? Which means it crosses 2 times. And in fact, look at this graph. Doesn't it cross twice?
Yeah.
That means that there are 2 solutions or 2 answers. Okay? So we're going to focus on quadratics, but I want to introduce you just a little bit to the third type. The third type is called a cubic. And we'll talk about this in Unit 3.
Funny cube Unit 3.
I know, right? Like how I did that? Okay, and for right now, we're just going to use the standard form of a cube as this. F of x equals x cubed. There's some more that comes after that, but that's not important right now. So we're just going to use x cubed. What does the graph of x cubed look like? Yep, kind of a wavy line. What is the degree here? 3, which means it should cross my x-axis how many times? 3. And look, 1, 2, 3. It does cross 3 times, right? Which means there are 3 answers, or 3 solutions. So for this unit, our focus is going to be on quadratics, but I wanted to introduce you a little bit to, you've already talked about linear, that's what you did in Algebra 1. You talked a little bit about quadratics in Algebra 1. And then in Algebra 2, we're going to focus on quadratics and cubics. Okay? All right, so down there it says, guided practice, label each term of the following sentences. I'm sorry, the following quadratic equations. Oh man, this scroll never works. Oh. Okay. All right, so if we look at this first example, what is the quadratic term of this first example? Anthony, what's the quadratic term in this equation right here? Which one is the quadratic term? X squared. Excellent. What is the linear term, Crystal?
Linear term is the last one.
Okay, look back up there at your notes. Right, it says the linear term is the bx. Look at your notes where we define linear term. It's the bx term. So which is the x term in this example down here?
The second one.
The second one. So just negative 10x is going to be our linear term. And then Emily, what's the constant? 3. Excellent. Okay, the second example is a little bit mixed up, but we can still handle it. Kaylin, what's the quadratic term? 2p squared. It's the x squared value. Good. Cynthia, what is the linear term?
Negative 15p.
Negative 15p. Austin, which one is the constant?
12.
12. Right, constant doesn't have any variables with it. Okay, the third example. Josh, what's the quadratic term?
Quadratic term is 5a squared.
5a squared. Excellent. Tracy, which one is the linear term? Negative 9a. Elena, what is the constant?
Would it be a positive 3?
Do you guys see that it's not in standard form, right? The negative 3 is on the wrong side. So Elaine is saying, hey, we need to add 3 to each side. I'm just going to maybe put it on the end. So the constant here is actually a positive 3. Nice job. Okay, so any questions about that part so far? Feeling okay? No? Okay. All right. Next page. We're going to practice evaluating stuff. This should be an old skill for you. But we need to be able to do this so that we can do what's getting ready to come up. All right, so we're just going to practice a couple of these. It says, oftentimes you will have to evaluate. That's your word there, evaluate. Oftentimes you'll have to evaluate a quadratic function given a specific input. All that means is they're going to ask you to plug things in and find the answer. Okay? So this first example says, evaluate f of 3 for f of x equals 2x squared minus 5x plus 10. All that means is instead of f of x, we need to find f of 3. Notice that 3 is in the spot of x. Do you guys see that? So that means in my equation, instead of an x, I'm going to write what? 3. So this should be 2 times 3 squared. And I'm going to put that squared inside the parentheses because it's the x that's being squared, not the 2. Minus 5 times 3 plus 10. Now, we don't do anything with the left side of the equation. We're just going to do on the right side. Okay, so I need to do 3 squared first, right? What is 3 squared?
9.
So then I have 2 times 9. Yep. And you can do that in one step if you want to. Minus 5 times 3, which is 15. Plus 10. Okay, so 18 minus 15 plus 10 go in order from left to right. So 18 minus 15 is what? 3, and then 3 plus 10 is 13. Now what is 13? Is x 13? F of 3. That means when you plug 3 into the equation, you should get a 13. That's what it's saying. When you plug a 3 into the equation, you should get 13. All right, try example number 2, and then check with your neighbor. If you don't have a neighbor beside you, find a neighbor behind you. Or in front of you. What it's saying is when you plug in a 3, you should get an answer of 13. That's what it's saying. Because you have the f of 3. The f of 3 means when you plug 3 into the equation for x, you get 13. Be careful with your negative signs. If you put negative 2 squared in your calculator, it's going to give you negative 4. Because most of you are doing it like this. Look up here for a second. Negative 2 squared, if you type that in your calculator like that, it's going to give you negative 4. The reason is because your calculator does order of operations first, and then applies the negative. Okay? But what is negative 2 squared? 4. So if you want to do it in your calculator, it has to be done like this to give you 4. But you shouldn't have to do negative 2 squared in your calculator. You should be able to do that in your head. Paula, what'd you get?
Negative 29.
Negative 31? Yep, and negative 31. Negative 16 minus 14 is a negative 30.
Oh, wow.
And negative 30 minus 1 is a negative 31. This is why we're practicing. Now it says h of negative 2, so you need to make sure that you use h of negative 2 as your answer. Okay, any questions on that part? Okay. The graph of a linear function is called a what? You got a linear function. What is a linear function? It's a line, right? So the graph of a linear function is a line. Ooh. And the graph of a quadratic function, we've already talked about it. What's it called? Parabola. Parabola. Also known as a parabola. No. Do you guys remember that Ebola stuff?
Yes.
Is that what it's called? Ebola?
Yeah, something like that.
Was it Ebola?
Ebola.
Ebola or Ebola.
And everyone was like panicked. Kind of like Zika. Oof. Okay. Depending on the sign of the coefficient, of the quadratic term, that you can go up or down. And we'll talk about that in just a second. So to determine whether your parabola is going to open up or down, you need to look at the a value in the ax squared term. So you're going to look at the a value in the ax squared term. Okay, a few more definitions. So again, if you are a highlighter, this would be a good time to highlight because these are more words that you're going to need to know for your first test. The definition of a parabola is the graph of a quadratic equation. And we're going to say quadratic function instead. And I'm going to abbreviate function with fxn. Yes, I know that there is no x in function, but that's just how we're going to abbreviate it, okay? So parabola is the graph of a quadratic function. It's the U shape. Okay, does anybody know what the axis of symmetry is? Crystal, what's the axis of symmetry?
The axis of symmetry is what you get when the points are on the line.
Close.
It's like the middle.
Brianna?
It's the line that goes through the middle of the triangle.
Okay, it's the imaginary line of symmetry. Okay, imaginary line of symmetry. Does anybody remember how to find the axis of symmetry? There's a formula. Who remembers it? Who remembers it?
It's like x equals b over 2.
Close.
It's like
X equals.
squared over x equals something over something.
We're close. Okay, the axis of symmetry. No. Is x equals the opposite of b over 2a.
I know it's x equals something.
The opposite of b, that's really important that you get the opposite. So I've just put a negative b, so if the b value is already negative, then it would turn into a positive, okay? So the vertex is the starting point. The vertex is the starting point of a parabola. It's like either the bottom or the top. And in Algebra 2, we use special letters to represent it. We use H, comma, K. H, comma, K just means it's a special X and Y point. H represents the X value, K represents the Y value. Okay, but it's right. Why don't we just use X and Y? Well, because the vertex is super important, so we just use H and K. All right, now, finding the vertex and finding the axis of symmetry, you're going to use the same equation to get started. So the vertex of a parabola also gets started with opposite of b over 2a. That's how you get started with it. Okay? Does anybody remember what the maximum is? Yes, it is the highest point. Of a parabola. The maximum is the highest point of the parabola. So what do you think the minimum is?
Lowest.
There we go. The lowest point of a parabola. All right, let's get into an actual example, shall we? Whew, it's a lot of notes. Okay, let's recall really quickly what is the standard form. Do you guys remember? F of x equals what? A, you're missing a letter there? There you go. There we go. You're going to need to know that. F of x equals ax squared plus bx plus c. Okay, and then what does a tell you? Do you remember what a tells you? Look back up here. What did a tell us? Whether the parabola does what? whether it opens up or down. Okay? So if A is greater than 0, that means it's a positive number. Brianna, you can move my computer screen down. You can just push it down if you can't really see. Pull it down towards you. There you go. Okay, if A is greater than 0, that means that A is a positive number, right? And if it's a positive number, the graph opens, what do you think? Opens up. So it opens up. It's going to look like this. Does it have a minimum or a maximum? Does it have a high point or a low point? Look, guys, it has a low point down here, right? So this is the minimum. So if it opens up, it's going to have a minimum. Do you need me? Do you need me? Oh, okay. Can I talk to you a break? 20 minutes?
Yeah, probably.
Okay.
I'll probably still be there.
Okay, Anthony, are you with me? Patrick, can you wake up? All right. Okay. All right. Just making sure. Okay, then if A is less than 0, that means it's a negative number. If it's negative, the graph is going to open down. And if it opens down, it has a good. It has a high point, which is called a maximum. Now, I don't necessarily expect you to memorize the minimum max thing. You can just draw it out, right? And if it has a high point, obviously, that's a maximum. Okay, the last thing on this that's really important is how do you find the vertex? So many times students start doing the problem and they can't find the vertex. And if you can't find the vertex, you're not going to be able to go forward with the problem. Okay, so how do you find the vertex? Anybody know how you find the vertex? Sit up for me. Yep. Okay, the first step in finding the vertex. Number 1. Use negative b over 2a. To find the x-coordinate. Once you find the x-coordinate, you're going to plug back in to the equation. I'm abbreviating the equation. For x, you're going to plug x back in to solve for y. So you're going to start with the opposite of b over 2a. That gives you the x-coordinate. And what's the other fancy letter that we use for the x-coordinate? The h. And then you're going to plug it back into the equation, solve for y. We're actually finding the k value. All right, so let's do one. Now we got the foundation done. Let's actually do one. Okay? So we're going to do this step by step so that no one is lost or confused. All right. Number 1 says y equals x squared minus 6x plus 11. First thing I want you to do is, what is the a value? What's the a value here? Brianna says 1. Does anyone else agree? 2 people agree. 3 people. 4. Thank you. Okay, I need you to be a little more vocal. Okay, remember there's really a 1 right here, right, in the front. And if you've forgotten, our formula is ax squared plus bx plus c. You're going to need to know where those are so that you can plug things in. So the a value is 1. If it's a positive number, is it going to open up or down? Okay, and I like to think of this. If it's positive, you're smiling, right? That's a smile. If it's negative, you're frowning. That's frown upside down. Okay? Hey, you laugh, but it's going to help you. You know it is. Okay, so if it's positive, I'm going to open up. Let me just maybe mention this hint here. If you tell me that it opens up, you should probably draw it opening up. I know that sounds bizarre, but students turn in papers where they say that it opens down, but they draw it opening up. And I'm a little confused at what they were thinking. Okay, so if you tell me that it opens up, please draw it opening up. All right, to find the vertex, remember it's step number 1. Let's do the opposite of b over 2a. All right, so the opposite of our b value over here, if you need to label it like this, oops. This is my a, this is my b, this is my c. You could do that. My b value is a -6, so the opposite of -6 is positive 6. Divided by 2 times, what's my a value? 1. Six divided by 2, 3. I had just found my first coordinate of my vertex. But remember on the back page, I said that the vertex and the axis of symmetry are the same, right? You start them the same way. And so if this is my vertex, this is also my axis of symmetry. Whatever the x-coordinate of your vertex is also the x-coordinate for your symmetry. And it's always an equation because it's a vertical line, right? It's a boundary line. The axis, I have no idea what just happened. Perfect. Let me try that again. All right, so it's x equals 3. We said our vertex was 3, comma something. Okay, so if I know that when I do opposite of b over 2a, I get 6 over 2, which is 3. What was the second step on the previous page? What did we say the second step was? Plug it back into our equation, right? So I'm plugging the 3 back into my equation. So if I have y equals x squared minus 6x plus 11, I'm plugging the 3 in for my x. Okay, so wherever I had an x, I'm putting a 3 because that was my x value. Okay, so why don't you evaluate that? That's why we practiced evaluating earlier. Use your calculator if you need to. Josh, what did you get for your y value?
2.
2? Anybody else agree with that? Good. We get -9 plus 11 gives me 2. So that is my vertex. Okay? Now, if you do not have a highlighter, quickly grab one. Because we're going to draw our x and y axis with a highlighter. So if you don't have one, quickly grab one, please. Do you have one? Ah. Go grab a highlighter, please. Go grab a highlighter, please. Please go grab a highlighter. Thank you. Okay, draw an x and y axis down the middle of your paper. With your highlighter, draw an x and y axis. Okay, now let's plot this. Please make sure you plot this carefully. Over 3 and up 2 is here. And I'm going to label this 3, 2. If you do not label, you will not get points. 3, 2, over 3 and up 2. Now we said our parabola opens up. Okay, so I'm going to open it up. And I don't really care right now how wide or narrow it is. So just draw a parabola opening up. This is Todd, everyone. Hi, Todd.
Hi, Todd.
Hi, Todd. He's just doing some inventory for us. Okay, so if my parabola is opening up, what's the other thing I need to draw? Anybody know? The axis of symmetry. And remember, it's an imaginary line, so to represent an imaginary line, you should be using your pencil, not your highlighter. Do you need me to turn? No. Do you need me to turn it off at all?
Nope.
Okay.
I just gotta lift it up.
That's
so you
fine.
can see our number real quick.
That's fine. Okay, so then the other thing that we need to. Oh, okay. What if I taught it like this? You guys guys are doing?
Honestly, be kind of down.
Everyone, lay down on the ground. Hold your notes above your head, in the air.
That would be awesome. Hey, can we do that?
No, because I do not want you sitting on this dirty carpet. That's why. And I don't have recliners. Sorry. Okay, so on the side, we're going to write on the side of the dotted line, we're going to write x equals 3. So x equals 3, anywhere along the side of the dotted line. Yeah. Can you put it, well, keep going, keep going, keep going. Good. Thank you. Yeah, thank you. Perfect.
My apologies for the interruption.
No problem. Okay, so do you see how I wrote x equals 3 along the side? Because that was my axis of symmetry. And so we need to make sure that we put it along the side. Okay? This graph now would get full credit because you've labeled everything that you need to and you have your dotted line axis of symmetry. If you just put 3 for the axis of symmetry, it's going to be wrong because it's an equation. Does this have a minimum or a maximum? A low point or high point? Minimum. Right. Nope. And we'll do that in the next lesson. We're not going to do that one in this one. We're just plotting. Okay? All right, let's try example number 2. Okay, we're going to do the exact same thing. You can go ahead and start. If our A value is negative, is our parabola going to open up or down, Patrick?
Down.
Good. Remember to find the vertex. We start with the opposite of B over 2A. If you need to label your A, B, C, that's fine. So you should be getting the first coordinate of your vertex to be 2.
Well, I did it -2 over.
Oh, you switched it. Okay, if I know that my vertex x coordinate is 2, Anthony, what else do I know? Remember how we did this part? They're the same.
Oh, yeah, axis symmetry.
And so what is my axis of symmetry?
2.
Not just 2.
X equals 2.
There you go. X equals 2. If you just tell me 2, you're not going to get full credit. Okay, Hortensia, what do we do next? What do we need to find next?
You have to plug the 2 into the equation.
Excellent. We're plugging in the equation, 2 into the equation. Aren't we really doing f of 2? Really? Right, because we're putting our 2 wherever there was an x. Okay, go ahead and figure out what it is. You guys getting -2?
Yes.
Okay. So that's going to go up here with my other vertex. All right, so with your highlighter, go ahead and draw your x and y axis. -2 is here. We're putting a V for vertex. It's supposed to open down. And again, I don't really care right now how wide or narrow your parabola is. Just make it go down. Josh, what are we missing here in our graph so far?
Invisible line.
The invisible line? Do you remember what the invisible line is called? The axis of, there you go, axis of symmetry. Okay, why would this graph not get full credit, Tracy?
Because you don't have the axis of symmetry.
Excellent. The axis of symmetry is not labeled. So this graph would not get full credit until we put this on there. Now we're getting full credit. Emily Harris, is this a minimum or a maximum? Maximum because it has a high point. Excellent. Any questions? You guys doing okay? No, not yet. We got one more to do.
Any questions?
Oh, I see what you're doing there. Okay. Okay, let's look at example 3. There is no linear term. Do you guys see that? The linear term is gone. There is no middle term. So what happens when there is no middle term? That is the question. So let's go ahead and start the problem as if we were doing it normal. Okay? So what happens if the linear term is missing? That's your blank there. What happens if the linear term is missing? Okay, let's check. Let's do some investigation. What's the A value, Devin? What's my A value? Do you remember where the A comes from? Yep, it's 2. It's just that number that's in front. Do we have a B value here? No, because there's no linear term, right? There's no something x. So what is B if it doesn't exist? 0. Okay, and this is my C term. I know that B is 0. Whoops. Is this parabola going to open up or down, Kaylin? Up, because the 2 is positive. Okay, to find the vertex, Anthony, what do we do to find the vertex? Okay, what's the problem, though? What's our B value? 0. Divided by 2 over 2. What's 0 divided by anything, though? 0. So the first coordinate of my vertex is 0. What else do I know now, Cynthia? If I know that the x-coordinate is 0, what else do I know?
That x equals 0.
Excellent. Your axis of symmetry is also 0, right? Because we said that these are exactly the same. Austin, how are we going to figure out the next coordinate of my vertex?
Plug 0 into x.
All right. Plug 0 in for my x. So I'm evaluating f of 0. 2 times 0 squared minus 4. Well, 0 squared is 0, and 0 times 2, that's just gone, right? So we get -4 for the other coordinate of our vertex. Excuse me. Okay. So we know our vertex is at 0, -4. So let's go ahead and draw our x and y axis with our highlighter. And if we're at 0, -4, 1, 2, 3, 4, I'm here, right? Down here. I know that it opens up. My axis of symmetry. Now, this might be hard when you're doing your homework to draw your axis of symmetry when it's on the y-axis. So this is what I want you to do. If you can't really see it, then I want you to just extend your axis of symmetry above and below. When you extend it above and below, right, because doing it along the dotted line is going to be kind of tricky. But you're going to label it x equals 0. Does this have a minimum or a maximum, Crystal? A minimum. It has a low point. Okay, so if the linear term is missing, where is our vertex at? It's on what? It's on the y-axis, right? You guys see that? It's right here on the y-axis. So anytime the linear term is missing, the vertex is going to be on the y-axis. That's your blank up there. On the y-axis if the linear term is missing. Okay, and then example 4 is just another example of it being on the y-axis, all right? Are there any questions? Brianna, what's your question? Can we go on break? Yes, let's go on break. Okay, I'll see you after break.